Some of you probably know this, but there's probably a larger group of you who don't. And that is a lot of my work involves thinking about how do you test code? How do you test the systems we build? How do you test them for functionality, for correctness, making sure that your systems don't harm your end users or do things you didn't expect them to do? I place a lot of value on being able to do that type of testing, whether that testing take the shape of unit testing, integration testing, end-to-end testing, or I know even, God forbid, manual testing. So as somebody who puts a lot of value on testing, what I wanted to do was share an example of one of the approaches I take in my own code to help make my code a little bit easier to test. Because what I find is that the more complex something is, the more setup that's required to test a method or a class or a system or multiple classes, whatever unit of code or unit of system you're going to test, the less likely it is to actually get tested. Now, the opposite is true. The easier it is, the less complex, the less effort it takes to set up, the more likely it is to be tested. And then even so much that those tests then are more likely to be repeatable. They're more likely to be cheaper in terms of time and money and effort. And those tests ultimately become more helpful to the actual development process of actually shipping software and actually building software that delivers value to users. So the example I wanted to show you today is a little contrived, but it illustrates this idea of dependency injection. So let me just kind of give you a lay of the land and orient you. I'm talking specifically about C# and .NET code in this example, but the idea of dependency injection really is language agnostic. It's just about being able to alternatively provide different implementations of something to the code that calls that something instead of having a hard-coded dependency that can't be changed when the method is called or the class is used or whatever unit of your system is being executed. So if we go into my service class here, you'll see I have this one class that sits in my library project, and this is just a class library, .NET class library. And then I also have a corresponding test project for this class library, and that just has a singular class that is my services test that tests the methods of my service class, right? I know the naming is great. It's wonderful. I'm very, very smart, very big brain. Naming things is hard. Don't make fun of me. And all this service class really does is it just focuses on what I'm calling saving settings. It basically accepts a dictionary of string to string key value pairs, and then it serializes those to JSON, and then it writes it to a file on disk. Now you'll see in my method here, I've got a lot of calls to static APIs on these static classes. So I'm calling path.combine, directory.create directory, file.write all text async. So there's a few different places in this method where we could probably talk about where dependency injection could be applied. But what I'd like to do is I'd like to focus on the actual, what I think is actually the most important part of the method, which is, do we actually take the settings that the caller gave us and do we actually try to write them to disk? Now, there's probably reasons why we wouldn't be able to write them to disk, right? We're at this point, when we call down to the file system, now we're dealing with another system, another thing that's sort of outside of our control, outside of our code. So this would be an example of a piece of this method that I would ideally like to swap out. I really just want to verify that my method tries to persist it to the disk. I don't necessarily care about what really happens or if it actually does get persisted, because some of that is sort of out of my control at times. So what I just want to do now is I just want to verify that, hey, when we pass you these settings, you actually try to save it, right? But at this point, I can't really test that, right? Or at least if I do test it, I'm sort of I have a hard dependency, a coupling with this file API that I'm calling. And so if we look at my test code here, you'll see I've kind of stubbed out a test for us where all I'm doing is I'm newing up a new instance of our service. And then in my test method, I'm creating a set of fake settings. And then I'm actually calling that save settings async method, passing it my settings. And then I haven't yet actually done the work of figuring out, how do I assert that the settings were in fact saved. And like I mentioned, could we call the actual file API, and then in our test code, could we try to locate that file and read it from disk and we could 100% do that. But in this context, what I want to kind of show is how we can sort of do this in kind of a true unit testing fashion, where we're sort of trying to isolate our code from code that we don't control, or APIs or other systems that we don't really have control over, like the file system, or for example, like a third-party API, using dependency injection. So what we're going to do is we're going to go back to my save settings async method, and we're going to take a look at this, and we're going to basically use dependency injection, but we're going to use it at the method level. So instead of using what's more canonical for C#, which is you're passing in a dependency through the constructor, we're going to actually pass in a dependency injection through a method. And this is why dependency injection can really be implemented in a variety of ways, and it's really language agnostic, because all we're trying to do is we're trying to say, hey, you have a dependency on this write all async call. Can we provide a way to swap that out? So either it defaults to write all text async, or and optionally our caller can give us an alternative implementation, or do we just always put the onus on the caller to tell us how they want that persisted, right? Because you could think, well, maybe you don't want to persist it to disk, maybe you also want to persist it to some database, or maybe you don't want to persist it at all, maybe you want to persist it into some sort of memory store. So in this case, what we're going to do in order to pull this dependency up and actually allow the caller to provide it, and therefore we can provide our own mock implementation in our test, is we're going to declare another parameter to our method, which is a delegate. And this delegate is going to have a signature that in this case matches the signature of the write all text async. We're just going to keep it simple, right? We just want to be able to swap out this particular implementation with an alternative one. So in order to match that signature, we need to pass a func with parameters of type string, a nullable string, a cancellation token, and then it's going to return a task. Now, as Copilot suggesting here, we could make this optional if, for example, we wanted to always default to persisting with the file API, if the caller doesn't give us a delegate themselves or an implementation themselves. But in this case, I'm just going to force the caller to always give me whatever the implementation is that they want to use. So in this case, we'll say save file async like that. And then down below, what we'll do is we'll just swap out the write all text async call with the save file async parameter that we expect the caller to pass. And now what we can do is we can go back to our test. So again, this is the whole idea of a dependency being injected. At this point, it's being injected at the method level, but it could be injected at the class level through the constructor. And then what we'll do is we'll go back to our service tests. And now this is going to complain, obviously, because we're not actually providing the save implementation, the save file implementation that we want. So we could say file.write all text async, and we just got rid of the text context accidentally, and everyone would be happy, and we'd essentially be back to where we were before. However, again, we're still left with this question of, in our test code, how do we validate that we actually saved the settings? Do we actually want to read a file from disk, or do we just want to be able to verify that we made the attempt? In this case, I just want to verify I made the attempt. So what we'll do is we're going to provide an alternative implementation. And let me just disable Copilot really quick so it doesn't try to get ahead of us. So we will say static. This will just be a static delegate that lives in our test method only for the purposes of this test. So we'll say static async task. And in this case, what we'll do is we'll say mock save file async, and we will define it as having a string. Let's see, we'll call this the path, string is the content, and then it also takes a cancellation token. This way it matches the signature of the delegate that our save settings async file expects to have. And for now, we'll just return a task.completed like that. And this is going to complain, obviously, because we have an async modifier with no await. And so now what we'll do is, instead of write.file all text async, we'll pass in our mock file async. Now we still have this issue of mock save file async. Now we still have this issue of, great, so how do we actually verify that mock save file async was called? Well, we can do this really simply by just having a boolean that we say var saved file, and we'll say this starts as false, and then in this method we'll set it to true like that. And this is going to complain because a static method like this cannot capture a variable in its scope. So we'll just change that from static to a non-static function. And then down here, what we'll do is, instead of saying assert.true, we'll say assert.saved file, like so. So now what we'd expect is, because we pass in the mock save file async implementation, our save settings async method should call it, and therefore it should set that saved file variable to true. Now let's see why this is complaining really quick. Nullability of reference type and parameter of content. Nullability. There we go. So now if we run this test, we should find that the test passes. I always say that without actually running it first, and then I make myself a liar. But if we give it a couple seconds here, we should see it should actually pass. And there's the green check mark. Yay! So here now we have a way to, without ever talking to the file system actually, we can just verify whatever implementation we pass to the save settings method, our save settings method does in fact call it. And again, like I said, if we really wanted to always default to saving it to a file, but we just wanted to have the ability to swap that out for testing purposes, we could set this to null, right? Give it a default value, make it nullable, and then we could also do a check here that says, if it's null, right? If save file async is null, right? We could just say, okay, well, instead of doing all that, let's just say write all text async. We'll pass in all our things and we'll return early. So if we really wanted to not have to have the caller always provide us an implementation, we can still have the benefits of dependency injection, but just make it optional for the caller to supply it, and we'll just use it for testing purposes. All right, I know that was a lot of words just to say dependency injection is helpful for making your code testable, but I realize that not everybody who's a developer or everybody who's writing code has had somebody actually sit down and sort of hold their hand and explain in very explicit terms why use dependency injection, or how do I make this code that I'm working on currently testable? What things should I be looking for that would be a code smell that maybe my method or maybe the class that I'm implementing is going to be difficult to test? And this is one of the things I'm looking for. Are there dependencies hard-coded in my methods or my classes that will be difficult to swap out for different implementations, or difficult to control what those implementations are doing when it comes time to test? All right, I hope you thought this was helpful. Obviously, if you think I made no sense or you think this is entirely dumb, I'm happy to hear from you all the same. You can find me on Blue Sky or leave a comment below. I'm learning just like you guys are learning. I'm just trying to share the things that I found helpful, the things that I feel like I'm doing to make my life easier when I'm building projects or writing code, and in hopes that maybe it helps you too. So with that, I'll leave you. I'll likely see you in the comments of a video, or in the chat of the stream, or in the comments of a short. And if I don't see you there, I hope you're having a great day, and I'll see you in the next one. Bye.